Hi, everyone. I'm here to talk about something that we're building, which is the interplanetary database. And it's a blockchain-style database for what we see is a developing world computer. So we're going to break all that down right now. So a bit of background first. We're talking about crowdsourcing today, but the internet that we're living on now has been pretty re-centralized. We are able to reach all kinds of different people, but their data is all being stored at centralized clearinghouses. It's kind of creating walled gardens. Now, those gardens are really fun to live in. The internet is easier to use, it's more convenient, it's more secure than the internet of the 90s, but it's far more centralized in terms of what you can do with your personal information. So let's talk about life in the garden. This is the Little Mermaid in Copenhagen, and I think we can all agree it's a very nice piece of city art. But Facebook kind of thinks differently. They say that some of our global audiences might find this type of content objectionable. So they've removed pictures of the Little Mermaid for having bare breasts. They've removed the photos of the Napalm Girl most recently from a photo essay about war journalism. So these community standards that we're living by and the information that we're seeing is really being handled at a lowest common denominator. And our personal information is subject to the same kind of common denominator. Facebook has a really strict real name policy, which is great for creating identity and great for confirming that we are who we say we are, but it's also kind of dangerous for people who might be victimized if their real name were made public or just don't want to go by their real name. So what it really comes down to is that if you want to play on this centralized internet, you have to play by their rules. And if you don't want to play by their rules, you can lose everything. You lose your identity, you lose your contacts, your conversations, your personal information, and this is the choice. So we're imagining building a better internet, one where you own your own data, and you manage your own identity and reputation, and where neutrality is built in. So if you want to switch to a different service, you can do that. So fortunately, this better internet is already being built. We're seeing a trend toward increased shared computing infrastructure, which means, ironically, despite being on a single global computer, that our information is more in our control. So what would this better internet look like? What would the characteristics it have to be? Well, it'd have to be decentralized, so that no single entity actually owns or controls the network or the data. It has to be shared, so the resources that we actually use, the physical infrastructure and the data, is controlled and shared amongst the participants. It has to be self-sustaining. It can't rely on handouts, otherwise it could be influenced that way. And it has to be planetary scale. Efforts to do this so far with blockchains have been really interesting, but they've been smaller scale, and they will not scale up to the level that we need to actually make this work on a planetary level. So what I'm going to talk about today is a piece of this emerging world computer. And this is a hard concept to get heads around. The idea that every single bit of computing infrastructure is becoming a single computer and can be used that way. So to kind of frame this, in the 70s, we started having one computer per organization. So if you were a big corporation or a big university, you might have a room or a warehouse that looks a little bit like this. Over time, we progressed to 1 or 2 or 3 computers per person. Now the computer that I have in my pocket is far more powerful than the computer that I had on my desk, or definitely more powerful than that one that was in the room a couple slides back. But we're moving towards a single computer for the entire planet. We're sharing all of these computing resources through blockchain technology. So the best way to think about this is kind of as a technical stack. At the very lowest level, we have the internet. We have TCP/IP, where all of this is being built upon. A bit above that, we have storage and processing. So for file systems, we have things like IPFS or storage. For processing, we have Ethereum. And then above that, we have the platforms for identity, for intellectual property, finance, energy, for Internet of Things. And then at the very top, we have the applications that people actually use on a day-to-day basis. So when we talk about this infrastructure, it's not things that people are going to have to interact with, but it's the things that developers are going to be building on top of. So what we really want to zoom in on today is the database. So that's IPDB. That's the database for the world computer. We've set it up as, first of all, a network of nodes that operate this public blockchain database, and a not-for-profit organization that's governed by those member nodes. So what can this be used for? We see one really obvious application as intellectual property. We come from the background of a company called Ascribe that was registering artwork on the Bitcoin blockchain. But we discovered scaling issues, so we decided to build up this database. And clearly, one of the best applications for it would be a registry for intellectual property. For identity would be another great application. Imagine a system where you control your own identity, you can certify things to other people without them checking with a third party. You could certify other people with credentials and be able to trust those things without going to a central authority to verify it. And for anything else, working with developers, we're hearing all kinds of wild and wonderful ideas for how this could be used. So the technical basis for it is BigchainDB. This is the company that spun off the IPDB. IPDB is actually a public version of this database software. It's a federated blockchain database, which means not an actual blockchain, but adding a blockchain characteristics of assets, of immutability, and of decentralized control to a big data database. So when we started thinking about this, we really wondered how it would be run. And governance is first and foremost in all of this. So for existing blockchains, we've seen real issues with this idea that code is the absolute law. Code is part of law, but there's also human systems at play here. So with Bitcoin, we've seen real challenges scaling the network up due to conflicts between the needs of the network and the needs of the miners. With Ethereum, we've seen the DAO crisis, which was supposedly a decentralized crowdsourcing platform that raised $150 million, but was quickly hacked and $50 million stolen from the system. So Ethereum left trying to figure out how to respond to that. So we realized right away that governance was going to be a real priority for us. And really, we said that governance comes first. And the first thing that we had to do was choosing the caretaker nodes. And they're really at the heart of IPDB. They are the members of the foundation, and they're the operators of the validating nodes. So on the foundation side, this means that they're going to be the groups that choose the board of directors, that make the day-to-day decisions. And they're also going to be the ones running the actual servers. So how do you choose these organizations? We set off thinking about who would be the people that we would trust with the keys to the internet. So obviously, they have to share a commitment to the decentralized internet, but that alone isn't enough. There's other things at play, like money. So we realized that more than half of these organizations should be not-for-profits. And this is both to prevent profit from flowing to the organizations and having them vote for direct financial gain, and also to keep them from steering the organization to indirect financial gain, like we've seen with ICANN, where domain registrars saw a chance to sell lots of domains like .sucks and .xxx, and voted to approve of huge expansion of the available domain space. Money isn't the only concern. Law is also a concern. So in order to deal with that challenge, we've said that less than half could be in any given country. And eventually, we're moving towards full decentralization, both in technology and in governance. So on the governance side, organizations tend to become comfortable. They like to stick around. So a nice, cushy job with an established NGO there's less of an incentive to actually move toward full decentralization. So we've built into the mandate that the organization must dissolve in the future. And decentralized technology. This is really the big question. Right now, there are no scalable technologies that can do what we want. There are none that can operate at this planetary scale that's so important. So we are pushing towards a serverless world, and we're not committed to any one technology, which means if technology emerges that allows us to operate this database without servers at all, that would be ideal. So here are our existing caretakers. We've established a great group of organizations. On the not-for-profit side, we have groups like Blockstack, like the Internet Archive, like the WeShare Festival. And on the for-profit side, Big Chain DB, of course, Scenario, which just did a very successful crowdfund, Protocol Labs, which is kind of our companion organization running interplanetary file system. And here's where we are right now in terms of actually building this thing. We have set up an internal test network, and that was quite successful. So now we've started opening it up to organizations to come and play with it. So if you have a project you think would benefit from this, feel free to come by and sign up, and we'll invite you to see what you can do. Oh, we're moving backwards. And that's everything. We have about 80 seconds if anyone has any very quick questions.
Right. Well, thank you.
Excellent. Thanks, Greg.
Thank you, Greg. Question for you.
Yeah.
You should stand there.
Sure.
Nikki, you have a question for him?
Yes, I was curious, Greg, how far away are we, in your opinion, from decentralized governance and decentralized technology?
Right now, I think we are working on it. We've seen the building blocks in place. There are various timeframes in place. In terms of this database, it's scalable right now. But we still need to build the actual social systems on top of that. Having the technology isn't enough. Mm-hmm. And for full-on processing, that's probably going to be another several years before it's quite ready. But it really is exciting and important that people are talking about it now, because it is coming in the next 10 years. And it would be nice to have governance, legal, social systems ready to go. So it's not just a technocratic system running things.
Excellent.
Anyone has a question for Greg? Tammy?
Two there.
What are your security measures for protecting the data?
In what sense?
If my organization wants to put on medical data and it needs to be kept private for the people who are getting medical care.
Right. I wouldn't advise you to put that on a public blockchain database. I would say that should probably be in a private database or fully encrypted before it's actually put on the database. So this isn't for all kinds of information. Sensitive personal information shouldn't go anywhere near a public blockchain.
Okay. I think we have to wrap up.
Great.
Thank you very much, Greg.
Thank you, Greg.
Thanks.
Yes.
This is for you.
Wonderful. Thank you.